in this video I'm going to introduce literals and variables. So a literal is a value that is not a variable. So 55 is literally the number 55. Hello is literally the string hello. Sometimes you do want values that are variable, such as age, for example. Every year you add 1 to your age or you increment your age. Similarly, you may want to count down from 10 to 0, or you want to add or multiply different values. Also later on in the course, we'll see how to enter values, type values in, from the keyboard, and then you want the program to do something to those. You want them to, you want to multiply to numbers, stuff like that. In that case, you want to temporarily store, well, at least temporarily store those values, and then you can use that result later in the program. So we use variables for that. So we'll talk about variables a bit later in this video, but the literals are different. So literals are simply typing out a value such as 55 or some string, as we had it in the previous lesson, where we simply typed hello world or something and we print that out to the screen. Okay, for this I'll create a new project. Empty project, C++ Windows console. To the left, you will get recent project templates. You can choose between those. We only have these few here, so it's easy to get to where you need to go. So I'll click Empty Project, C++, Windows, and Console. Okay, I'll do that. Say Next. I'll call this Variable Demos. And again, you can change the location here. So click this here. You can see we have that Hello World demo that I showed previously. And we have the namespace demo. So you can save it where you want. I changed that in the first few lessons and now I'm kind of changing back here. Of course, you can change the solution. If you want a different solution name to your project, you see if you change this up here now, the solution will not match. So it only matches initially until you decide to change the solution name. So I'll just keep those, have them be the same. And that's it. I'll just go create. Again, this is good practice. Go in here, add a new item, call this main.cpp, and I'll add that. So we've seen how to output things at this point. So actually I'll go up. We need to specify the namespace. So alright, so let's just print something out to the screen. And we want to return 0 as well. So what I like to do is I like to press enter a few times just to get this kind of out of the way of where I'm focusing. So this here, you can have it be hello or something like that. This is a string literal, so whatever is between these double quotes is a literal. Go to debug, start without debugging, and here we get that literal string that gets printed out. So you can change this, of course. Hello, Control F5 to run that. Okay, so again, this is the literal string hello. You can change this to some value. So 3, for example, you can just enter 3, Control F5 to run this, and we'll print out 3. And that is the literal value now, 3, or 97 as we had it before. I also mentioned that you can chain these by using this operator right here. So what I can do is I can do another one here, and between these two, I'll do something like this. So here what's important to notice is that between these double quotes, it will print out these spaces too. If you enter space here, it's going to leave the space right before you see the value. So we want to do another one here. Another string literal. So I'll enter. First, of course, I want a space right next to 97. And then I'll do like that. years of age. Missing a dot there. Okay, Control F5 to run this. And you can get a result like this. So the point is you can chain these together. And if you take those spaces out, Control F5, you can see these strings now are too close up to the 97 literal. So just a quick trick for you. So here again we have string literals, and here we have a literal integer value. You can also do characters like this. Okay, now that will put out that character. So Control F5. So in this case, this is a literal character that has 9 in there. These are strings. The character shows up between single quotes, whereas strings are written between double quotes. We'll talk extensively about strings and characters a bit later. Next, we'll talk about what a variable is. If we want a value like this, so 9, if we want to save our age out, how can we do that so that we can add to it, or we can enter it maybe from the keyboard into our program, like right here, maybe, okay? Before we come down here and print it out, how can we do that stuff? Well, first we need to talk about how we can store these values in memory so that we can use them later on in our program. Next, let's talk about variables. So how do we store data during program execution? You might need variables or a value that is variable, that can change for things like how much health does your character in your game have, how much health does it have left, what type of values does a character's health or name represent, so whole numbers, floating point numbers, strings or characters. So we'll talk about integers in this lesson and this video. Primarily, those are ints or integers. We'll talk about floating point numbers and strings in a bit more detail later. Okay, we can define a variable as a named memory location of a specific type that we use to store data to or retrieve data from, the value of which can be modified during program execution. Okay, so that's an important thing. It's a specific type. Okay, we give it a name and it's a specific type, and we can modify that during program execution. So actually in module 1 or 2, we'll see that there are some complexities with regards to this. So we can actually create a variable that does not have a name or identifier, also often referred to as a handle, attached to it, but that is kind of outside the scope here. We want to kind of keep it simple. So for most of the variables we'll be using in the first module, we'll attach a name to it, okay? So you can think of it as a named memory location. So it's an abstraction for a memory location. So this means that we don't have to worry about like exactly where it is in memory, the memory location. We can simply use the name. You can think of it as a container that can hold or store a specific type of data. And again, it allows the programmer to use meaningful or memorable names instead of using or working with memory addresses. Okay, so how do we store the values in memory? Okay, we have these variables, such as age, for example, right? We want to add 1 to that every time, or we have 2 values, 2 whole numbers that we want to add, and we want to then store the result in another variable because we want to leave the first 2 alone, for example. So how do we store that? Well, we store that in RAM or memory. So we have RAM, random access memory, and we can use any part of it at any time. So you can think of RAM as this chunk of memory that is kind of sliced up into these containers, almost like parking lots, right? And each one has a number assigned to it. So RAM is volatile flash memory, and this simply means that when the computer shuts down, the contents of RAM memory is cleared. Now, data could be lost if not saved permanently. So of course, permanent storage here refers to your hard disk drive, so HDD, or you probably have a solid state drive, an SSD, or a combination. So often these days you have solid state drives for your main programs, operating systems, and so forth. And then your spinning disk drives, your older hard disk drives, are cheaper per gigabyte, at least at time of recording. So sometimes you have a combination of these, right? So those are your more permanent storage solutions, whereas RAM you can think of as more like a temporary storage, right? If the power goes off and you don't save your stuff, then you lose that. Why? Because it's not saved. So you save it, you cache stuff out to disk, and we'll actually take a look at that in module 2. We'll take a look at how we can read files, read stuff from files into our programs, and then manipulate the data contained within those files. And we can also create and write files, so write stuff out to a file from our program. So that is a more permanent kind of storage when you write stuff out to disk. But when you're writing your program and you use variables, those are stored in RAM. So here's a quick example of binding the variable name and the memory location. You can see that we have the variable int age. So age is the variable name, but it is of type int. Okay, so it's important to have a specific type. Then we can see that we have this memory layout. You can think of this as a RAM, where you have a number assigned to each slot, and you can put something in that. Also, different types of variables use more or less memory. So we'll talk about that a bit later. A double, for example, is similar to a floating point variable, but you can have much bigger numbers. The problem with that is it uses more memory. So you have to kind of pick wisely, but for the most part, we'll use simple types in this first module. So here we can see we don't have to worry about where the variable is stored in memory, okay, in which memory location. And the reason is that we can refer to it by name. We can simply use the variable name age to refer to that value. Now, when our program starts, that memory location might have what's referred to as chunk in there. So that might mean that the variable age is declared, but it is not initialized to some custom value. So if we want to initialize it to 97, we have to do that, okay? We have to declare it first and then initialize it. We'll talk about how shortly. But the point is, when we declare that integer called age, it's going to be stored in memory somewhere, some space that is available, and then we can add or assign, a value to that and change it during program execution as well. The problem is, as I mentioned, RAM is volatile. So when we close the program, run it again, or the power goes off and we turn the computer on again, and we refer to that memory location again, where age is stored, it will most likely not be the exact same memory location, because it's going to basically look for a space that's open, that is available, okay, that is not used by some other program. So it would not make sense for us to worry about the memory, the memory location. And that's another reason why we use variable names instead of worrying about the actual location where it is stored.